Hello and welcome everyone on this another video of OpenCV tutorials, and today I'll be showing you simple threshold images. So let's get started. So firstly, what is threshold? Thresholding is a very popular segmentation technique used for separating an object from its background. The process of threshold involves comparing each pixel of an image with predefined thresholding value, and this type of comparison of each pixel of an image to a threshold value divides all the pixel of the input image into two groups. So first group involves pixel having intensity value lower than the threshold value, and the second group involves the pixel having intensity value greater than the threshold value. And using the different threshold intensities which are available on OpenCV library, we can give different values to this pixel which are higher than threshold value and which have intensity lower than the threshold value. So let's see how we can use simple threshold in image. So to start with, I have a simple code which loads an image on the window, and this image is called gradient.png. So let's run this code and see the image that I have uploaded. So as you can see right here, this is the gradient image that I have uploaded. So on your left, as you can see, there's black, and on the right that is white. So it is ascending or descending, as you might see, from black to white, or it is changing the color. So one, two, three, start. So as you can see in this image, we have on the left hand side the dark values, and when we gradually move from left to right and towards the right value, the value of white gets increase. So on the left hand side, the pixel value are closer to 0, and on the right hand side the pixel values are closer to 255. So we are going to just involve some thresholding technique, and we will see how these images will be affected by thresholding techniques. So here we are going to do is we are going to define two variables. One is underscore, which is because the result of thresholding gives two results, and one is RET. Let me just give RET, and let me just give a name here, and CV dot threshold, threshold, and we have to give the name of the image as a date variable img that we have given, and we have to give the threshold. So here I'm giving 50 and 255 as a threshold. So I'll explain you these numbers in a while. Let me just first write the code cv dot threshold binary. So the output right here, the output came of the inverse threshold. So as you can see, this window th1, our previous output right here, the black was on the left and white was on the right. So on this th2 output, it's the inverse, it's the opposite of this. Is because we are using thresh binary inverse, so the output will be inversed. The color of the color coordinate will be changed, the zeros and the 1 will be mismatched. So let me just change the value and let's see the output. Let me just close the previous outputs and let's see the output of the change value. So as you can see, when I change the value right here from 50 to 200, it changed. This is because, as you can see, the gradient image, the image that has lesser value than 200 will dominate the another color, that is the black, which is right here. The black is being dominated as because the color value of white is greater than 200. So this is the output. So using another type of trace variable, another type we'll use is trace trunk. So let's use this th3 and let me just copy, Control C, Control V, th3 and change the name from binary to trunk. TRUNC. So let me just show the output. IMSHOW. And I'll show you the output and explain to you what threshold trunk means. So the output is right here, and let's see the output of this new output. So THC that we have run, as you can see right here, the output. Let me explain the code. The threshold trunk is used as you can see, the original image, the white and the black are separated indefinitely. Right here you can see, and on this output you can see from the 50 mark that we have given, the threshold is 50, the changes are stopped, and you can see it's a constant color, it doesn't change. So trace.trunk helps you with that. It changes color till the image data or the image threshold is 50, and from that 50 mark point it doesn't change, it stays constant as a same image color. So moving on and to another thresholding technique, now is threshold to 0. So let me just copy this and change some names right here, and we are using threshold to 0, that is TOZERO CV dot so let me just run the code and I'll explain to you as the output comes up. So let's see the output of threshold to 0. So here we got threshold to 0. So let me explain this. Threshold to 0 is used, as you can see the pixel mark, that is 50 right here. So when the pixel mark reaches 50, it 50 or below, it automatically turns to 0, that is black. 0 means black and 1 or 255 means white. So when the pixel limit or threshold goes under 0 or below 0 or below 50, I mean, it becomes black, and when it is above 50 the pixel value, the image will be same or as the original image, as you can see right here. So moving on with another thresholding technique we are using, that is threshold to 0 inverse. So let me just copy this, threshold to 0 underscore inv. Copy. Let me just close all this output and run the new code. So let's see the output of th5. So here we got the value of th5. So as you can see, threshold to 0 inverse is basically threshold but inverse. So here when the 50 pixel mark or the threshold comes on the image, the 50 mark, it will be inverse. Previously, as you can see, the th4 here, the value when the 50 value was reached, 1, 2, 3 start. So previously on the th4 threshold to 0, when the 50 pixel mark was reached, it turned into black, that was 0. So, and when it was above 50 pixel mark threshold, it turned into white. So similarly th5 is the same concept but inverse. So when it hits 50, it will be the similar image, and when it is above 50, the image will be black or turned to 0, that is black. So thank you for watching. This is the end of the video. Hope you understood thresholding on image, and see you next time.